Hello, I'm Paul Nelson. I'm here to talk about JMP, Python, and our next step. After one of the previous presentations last year, we decided we could up our game. JMP, Python had room for improvement, and that's what I'll be talking about here. The biggest challenges that the customers had with JMP 14 through 17 was just getting the Python support to work. If it worked, it just worked fine. All too often, that wasn't the case. With numerous Python distributions and different environments, it made testing difficult for us. Anaconda could be made to work on Windows sometimes, and Python virtual environments could be made to work sometimes. The environment, because everybody had different Pythons, a script couldn't even depend on a common Python version in the user's environment. Editing Python code in the JSLN editor was difficult and unpleasant. A language that blocks of code are delimited by spacing. When you have to paste that in as a string in JSL, it makes it challenging. There's insufficient error reporting in the old versions of JMP from Python, made it difficult to debug your Python scripts. And finally, the data table and matrix transfers were done through the file system. And with a data table, it was done as a CSV file, which is slow if you've got actually big data. Big class works fine, but bigger data is slow. The vision that we've had is to make sure Python integration just works. No configuration necessary. To that end, we've embedded a Python version 3.11.5 in JMP 18.0, and it is installed as part of JMP. It's a common environment, and all users will have the same version of Python with the same version of JMP. We've gone further and made sure that data flowing between JSL and Python is in-memory transfers and zero copy access to the memory. We've made it an inviting and productive environment for Python programmers. We now also have a Python script editor where there's code coloring and syntax highlighting. You can run pure Python scripts directly from the script editor, and from within the Python environment, you can get direct access to JMP data, the log. You can call JSL and access data from Python. We've greatly enhanced the error reporting to the JMP log and the embedded log. Because it's a common environment now, we can test it and verify it. So our environment is the same as you should see. We've added an entire Python category in the scripting index to explain and to show samples of what's now available with the import JMP package and a couple other utility packages. The other part of this is this gives us the ability to extend JMP's capabilities through Python's vast library of packages. We're not attempting to make a one-to-one alternative to JSL. Instead, we're trying to provide a familiar and productive environment for Python programming within JMP. This is modernization, a revamp, and overhaul. Some of the original design decisions for JMP's Python integration provided limiting. We have made every attempt to minimize the breakage due to the change, while providing a strong and stable foundation for the future. There's every expectation that the breakage is limited to this transition to JMP. One of the key aspects is we now only support the Python version that we are shipping with JMP. Think of it as a private JMP virtual environment. The other thing that will happen in the scripts is we've changed the way Python send of a data table works. It now creates a JMP.data table object. This is live access to the JMP data table. In-memory copy, you can edit and modify the existing table. It's no longer a copy. Jump 14 through 17 created a pandas data frame object by copying the data through a temporary CSV file in the file system. For large data, exporting to CSV blows up. It becomes very large and slow. You also have the issue of potential loss of precision because you're going from a binary to a text format and back from text back into a binary form. If you really need the same functionality, we've provided the DT to pandas Python in the sample files that provides a to pandas function. This works the way JMP used to do internally. It creates a temporary CSV file and tells pandas to import the CSV file. There's also a jump to pandas sample showing how to create a pandas data frame in memory from a JMP data table object. That's building a column in pandas with a column from JMP, column at a time. The Python send matrix was another one that used to write through the file system. It would write a file of doubles to have NumPy read the file. This now happens through memory internally, and it's a live reference to the matrix instead of a copy. So majority of the JSL Python API remains intact. The changes involved were primarily removing deprecating arguments and functions used to configure the original Python support to pick a version of Python. The only API removal, was the Python get graphics function, which retrieved an image from matplotlib. And in our scripting index, we have a sample that shows exactly how to do the same thing that JMP did internally with just JSL and Python code. So show it already. Let's see. Let's get out of the demo. Here we have JMP. One of the things I want to show is you'll see Python icons in the toolbars, and in the file new menu, we have JSL script, but we now have new Python script. So we'll bring up Python script editor. We can show the embedded log, and we have a JMP import package. Import JMP. And we've made our effort to make sure we've put Python document strings so that you can run help JMP. And we can run that script, and you'll see we've documented the objects and functions within this top-level JMP import package. There are a bunch of constants, so most of the special directories are represented. So we can now do from Python, open, JMP, open, JMP. Boy, I can't type today. JMP dot sample data plus big class. Just like in JSL, we can select a line of code and run it in the script indent. And we have big class. Now, this is not a copy. We can get that object. We could have put DT equals JMP open and we'd have a reference. But we can also go DT equals JMP dot current. And that'll give us a reference to the current data table. Now we can do things like print DT. That tells us it's big class, it's 5 by 40 columns. But even more fun, we can do DT name. And we can use Python slice operators. So I'm telling it to give us every other name in the name column, starting with 0. We index in Python, just like Python should. We index starting with 0. Our data table index is column by row, since we are a column major kind of format. And if we print every other name, we get Katie, Jane, Lily, James, Barbara, Susan, Joe, and David. Now, this is live access, so we can do things like print, we can do things like DT, and we can use either name or the column index. So column, so we print that. That gives us Katie. 0, 0. I picked one, right? Louise, sorry. 0, 0 is Katie. And since the data table is live, we can do Katie. We want it lowercase, mixed case. Now we see the output in our embedded log. You'll notice we've changed it in the data table. This gives you the ability to modify data tables, access the data tables in a Python way, and you able to create data tables from Python. We've given a lot of effort, so we are now have the scripting index. I will show the here. Like I said, Git graphics is deprecated. It actually no longer is a valid function in JMP, but the sample in the scripting index shows you how to go from what you used to have to how we did it, how we actually did it internally within JMP. Save the figure and open the image and create a new window with the image. A lot of the nice new features of the Python-centric environment, they are in the Python category. It's a category all to itself. The JMP import package has data table objects. There's samples for each of the ones. We can create new columns. We can add rows. We can save the table. The properties on it, such as getting table names, all of that. This one would create a new data table powered by Python. So that's, we also have the a JMP utilities where you can or we can use it to run the pip. JMP, because it's made its own isolated environment, when we install packages, they need to be into JMP's isolated environment. So hopefully you should not run into any issues with packages you have in JMP conflicting with other things or other installations of Python. We've kept it isolated. And so in this case, if you have to, we've got create JPIP will create a script that will wrapper Python pip script allow you to install, or you can actually run it from the jump utils class from within jump. So here we'll show list, pip command list, and this will go out, call pip, and returns the list of packages that I have installed in my Python environment. Another example here, you can actually install packages, and that shall run straight from within jump. There are a couple caveats, which is why the create jpip exists. If a package is loaded in memory, like NumPy, since it's got a shared library, Windows may prevent you from updating that package. And there are some packages that require compilation. Those may have to be done from the command line. Some of them may work, but those may need to run from the command line. And that's why you'll want to create a jpip wrapper script. And when that's run, it will pop up and give you a directory in which to write the file, and then select folder, and it will write out a jpip wrapper script that's runnable from the command line. And there, when you run it, you'll want to use the -- user flag after install. We do that automatically for you within when it's called from here. And there's also a JSL function that will run the install as well. So Python install packages is even simpler. You can just run the JSL script and it will call pip in the background, properly setting up all the environment variables necessary to put the package into Jump's isolated environment. Let's go. So then we can go on to show you some more of the demos. This is the easy basic stuff, but what we also, part of this whole process was to make Jump more friendly to Python and much easier to extend Jump's capabilities through additional Python packages. One of our frequent support track that people desire is to be able to import Parquet files. So this demo takes and pulls a table from my drive, one that I downloaded from the internet, and then prints out the shape of the Parquet file and builds up a Jump data table column by column from the data in the Parquet file. So clear the logs, actually see me do it, and run the script. And I must have had some things highlighted. There we go. So this was a Parquet file that we did the pi arrow, Parquet SPQ, imported it. The Parquet files properties, it's 1,000 rows, shape is 13 columns by 1,000 rows. Schema shows prints the schema out, the column names, and here at the very bottom, we can show one of the other things is we're not done yet by a long shot with the things we want to improve on the Python side. But until we get there, you can run JSL from the Python. So even though the Python code does not yet support things like setting display widths, or even changing column types. You can create a new column, but you can't change its type from Python. Those are things that we want to get to, but right now you have a workaround to work through, being able to run JSL scripts from within Python, just as you were able to run Python from within JSL. Now, with this enhanced environment, you can call back and forth between the two. So the Python can run JSL scripts, which call in the Python can then run back in the JSL environment. So you can nest the calls to achieve things that would otherwise not be possible. So that's taking a Parquet file, a data type that JMP doesn't natively handle, but we've done that by importing a Python package to support that. One of the other things that's dear to me, I'm not much of a statistician, but I am graphics and other math. So here's using Open Compute Language, OpenCL. We've imported the OpenCL package to create a Mandelbrot fractal. Let's show you the CPU first. Doing it with the CPU, this actually will take about 16 seconds to run. Show that clock. This is painful, and you'll notice JMP itself is slow, not responsive, because Python has control at this point. And we have, if you put a run JSL wait deep inside tight loops, you will be able to regain control. So there, this is using the CPU to generate this fractal. But now let's change it to so that it runs the GPU instead. And run the script. Boom. That takes a fraction of a second to generate the image, save it out, and open it up into a script. And let's see what we say. So it took 0.16 seconds using the GPUs versus we're back far enough. It actually took 32 seconds while I'm here presenting to do it on the CPU. So this opens up, if you want to utilize the GPU with JMP, you're now able to do that through the Python. We've tried both the PyOpenCL and the PyCUDA. So if you have an NVIDIA card and you're working with CUDA, you can bring in the PyCUDA or a more generic OpenCL. Further enhancing JMP's compute capability, not leaving power of your desktop unused. So we can also connect to SAS over Python. SAS has a SAS Pi package, and we've installed that into the, and this is, some of this work is stuff that one of my coworkers put together. Let's clear the logs so we actually see what I've got. And we can run the script. And it's connecting to SAS, should be. That's wrong. All right. So here we go. This one actually uses the JSL to try and make sure all of the Python packages are already installed that might be needed to run the script. And you can set that up. And that's part of what you see here in the log was saying those are already satisfied. And so here's all of the results that came back from running the script, connecting to SAS using the SAS Pi package. And we'll go back through the log. The script is echoed to the log. Like I said, here we have connection information where it's connecting to SAS, running the proc logistic. And then returning the output values and the end of the SAS session. I've heard TensorFlow might be a thing that people are interested in. Here's a really simple one. Log. Again, I've installed TensorFlow, and this is running from JSL, but we could have easily just ran this code here from Python. And it runs the TensorFlow, creates the sum. I'm sure you'll come up with much more complicated uses than I have to demo. High digest is another one. It's screen. Here was a sample I created to show, one was to show several of the things, including the run JSL, where allows me to pick a directory using JMP's pick directory, the JSL's pick directory, and use that in a Python script. This is all pure Python script. It allows me to pick a directory, creates a checksum of every file in the directory, puts that into an SQLite database, and then creates a JMP data table from the database. So gives you a bit of database programming, gives a bit of creating a JMP data table from Python, and running JSL from Python. So directory to pick. Got lots of data here, so let's just pick the presentation, the Parquet folder, select folder. So now we have a table of checksums. It checksummed every file in the directory, gave me their path names and an MD5 checksum of the contents of the file. Built the database, built the JMP data table from Python, and also used the JSL to set the column widths. Again, that's something we've not implemented yet, but is something on the list to look at. But you can do things you can do JSL things from your Python if you choose to. Here that some people might want to use R. Well, in this case, I have created a connection using rserve. On my machine and in our environment, it was just easier to run rserve from within a Windows System for Linux WSL environment. So I have an rserve daemon running over here, and using the rserve client, I'm doing just a small little creating an R vector on the server, summing it, result. So, and run this script. And we've connected to our server. We get the vector, and we summed all the elements to get 6. Our pi2, there's also some examples of that we have. And if you want something really simple that will work from the command line, there's a sample on how to use subprocess to shell out and run R from the command line. And finally, the statistics one, where John Saul is helping him create a sample that used HDBScan Python package. One thing to note with Matplotlib, Matplotlib on Windows does not have a graphic backend. So if you want to see any output, we found that PyQt5 works best as the backend. And on the Mac, if you use Matplotlib, we will either force it to be the AGG, the non-graphic backend, if you haven't installed one of the PyQt or PySide, because Matplotlib on the Mac automatically goes for the Cocoa backend, and there is a bug that when you close the last window in Matplotlib on the Mac, it will cause jump to exit. So to protect against that, we are forcing, if we find Matplotlib on your system, if there's a Qt backend, we will load Matplotlib and force it to use the Qt backend. Otherwise, we make sure it's a non-graphic backend. So with we've made it the backend. I have PyQt5 on my machine. And with this sample, we run some clustering on the HDBScan. Now let's show the embedded log. And we'll run the script. And what we get is a figure generated in Matplotlib. We have a table of the data. And here you can see we did a jump open, and we took the DT reference. Those are the samples I have, I believe. And bring back the presentation. So our priorities for the near future: continuing refinement and improvement, increase the data interoperability between JMP and Python. Right now, the limitation within the column modification editing is you can create columns of any type, but you can only modify and get values for numeric and character columns. Expression columns, row state columns, creation of linked tables are all to be done in the future. While the Python script editor supports code coloring, syntax highlighting, it doesn't yet do automatic indentation support, and we will be looking at that as well. Goals for modernization was to make JMP Python integration just work. Out of the box, you should be able to be productive with JMP and Python without any configuration that was, if it didn't work, was very challenging. Wanted to reduce the time for Python programmers to be productive within JMP and make improve JMP's ability to be an analytic hub because of the easy expansion of JMP using external Python packages, and improve our ability to load different data formats that other people have spent time to write, like the Parquet format, where we HDF5, we tested that as well. So there's lots of formats out there, more formats than any one development team can have time to write internally. But with this way, you can pull in the Python package and you can make it a JMP data table out of that data and have that power within JMP. Appreciate your time. Hope you have enjoy what we've done, and very interested in feedback. Thanks.